Today we conclude our discussion of GCMs, Global Climate Models, with an examination of the predictions of such models. The major points of this video segment are: Number 1. Global climate models are tested by comparing their simulations of past climates with the actual climate record. Number 2. Global climate models affirm that human-generated greenhouse gases have been the major cause of the rapid global warming observed during the last few decades. Number 3. According to global climate models, average global temperatures will warm somewhere between 1.4 degrees and 6.7 degrees Celsius from 1975 to 2100, depending on human activities. Number 4, and last, average sea levels in 2100 will be 0.53 to 1.43 meters higher than in 1975. Once we input values for the past, present, and future greenhouse gas emissions, global climate models can sum the total of all climatic forcing factors and calculate the past, present, and future of Earth's climate. Verifying a GCM involves simulating the climate for past times and comparing the model's output with what actually occurred. Discrepancy between the climate simulation from a GCM and the climate record indicates problems with the model's assumptions, the algorithms, the initial conditions, the coordination among various submodels, or even the climate record itself. The Intergovernmental Panel on Climate Change, the IPCC, in its fourth assessment report released in 2007, presents the results of 16 or more GCMs that simulate Earth's climate under a range of scenarios for natural and anthropogenic factors. The models accurately reconstruct global temperatures over the last 125 years, separating the influence of natural, for example, orbital variations, and anthropogenic, for example, additional greenhouse gases, indicate that human activities are responsible for most of the half-degree Celsius rise in global temperatures experienced from 1970 to 2000. Several other lines of evidence support the conclusion from GCM simulations that human-generated greenhouse gases, not natural climatic variations nor urbanization near land-based weather stations, are largely responsible for recent global warming. Number 1, changes in solar variations from 1750 to 2005 account for a warming force of only 0.12 watts per meter, whereas human activities account for 1.7 watts per meter. Number 2, global nighttime minimum temperatures are increasing even faster than daytime maximum temperatures. One would expect the reverse to be true, where variations in solar electromagnetic radiation driving global warming. Apparently, higher concentrations of greenhouse gases enhance the flow of electromagnetic radiation back from the atmosphere to Earth's surface during the night. Number 3, temperatures in the lower stratosphere, the region of the atmosphere that extends from 14 to 22 kilometers above Earth's surface, are declining, while surface temperatures are rising. Again, this is consistent with higher concentrations of greenhouse gases retaining more energy near Earth's surface. Stratospheric and surface temperatures should rise at similar rates if variation in solar electromagnetic radiations were driving global warming. Number 4, a portion of the measured rise in global temperatures may derive from an urban heat island effect. The urban heat island effect is where many weather stations that were once in rural settings are now surrounded by asphalt and thereby record warmer temperatures. Location, location, location may be a major factor in weather records as well as in real estate. Nonetheless, measurements from a large global network of sea-based weather stations indicate that Earth's oceans have warmed during the last century in a manner that parallels the warming of land-based weather stations. Urbanization near weather stations thus seems unlikely to be the major cause in global warming.